Hi friends, previous video I have talked about the conventional fuel injection system. This video I am going to explain about the electronic fuel injection system. What is the electronic fuel injection system and in what way it is different or advanced over the conventional fuel injection system? First of all, why electronics in the fuel injection system? As the population is increasing and the lifestyle and affordability of the people are increasing, the automobile population also is increasing. Same way, the mechanization in the construction industry and mining industry is increasing. Now there is no any work without the mechanization. So whatever the machines operating in the construction mining machinery, all machines are, majority of the machines at least are powered with the diesel engines. So overall, the automotive fleet, the automotive engine fleet is increasing globally. Means the more amount of fuel we are burning, the more amount of fuel burning, the more amount of exhaust emissions in the atmosphere. So, which is giving negative effect on the nature. That is point number one. And it is also necessary to conserve the fossil fuel for the future generations. We have to get the maximum power from every drop of the fuel burned inside the engine. So to get the more power and also to minimize the pollutants in the exhaust gases, electronics are introduced in the fuel system. I am going to talk about the each and every component of the electronic fuel system in this video. See, this is the schematic diagram of a electronic fuel injection system, a particular model actually. This is precisely called as the hydraulically actuated electronic unit injection system. This is also can be termed as the common rail diesel injection system. How this electronic fuel injection system works, which are all the main components in the system and how they works. This is the schematic diagram of the electronic fuel injection. There are two circuits are there. One circuit is exclusively for the fuel flow. This is the fuel tank. This gray line is the fuel line. This is the water separator and also pre-filter. Here, the whatever the moisture or water is there in the fuel, it's trapped here because water should not be entered into the chambers because to safeguard the injection components. Then again the primary filter. Some more impurities are filtered here. Then it's going to the fuel transfer pump. This is a gear pump. Normally it will be gear pump which develops pressure up to 40 to 50 bar approximately. So from this again, this is the secondary fuel filter. From secondary fuel filter, the clean filter is always available at the injectors. These are all injectors. 4 injectors on one bank, the 4 injectors in the other bank. So this is V8 engine injectors. So fuel is always available with 40 to 50 bar always at injectors. If the fuel is not injected, the fuel is returning back to the tank. It is returning back to the tank from both the banks. This is called fuel circuit. This circuit only helps to keep the fuel readily available at all injectors with some desired pressure. Here is a pressure regulating valve is there in the return line. The next circuit is high pressure oil pump, which is used to actuate the injectors. In case of conventional system, there is a mechanical actuation through the camshaft and tappet rollers. Here the actuation is taken place through the hydraulic pressure. This is the hydraulic pump. Okay, this hydraulic pump takes the engine oil as the fluid media. This is the engine oil pump. This is the oil cooler. It takes from the sump, supplies through the filter to the pump. At the inlet side, the oil pressure will be approximately 4 to 5 bar, and when it comes out of the pump, the oil pressure will be, this dark line is the oil pressure. This light gray line is the fuel pressure. Okay. This oil pressure will be from 100 bar to 250 bar depending upon the requirement of the system. The pressure varies depending upon the requirement of the system. How the pressure varies, that I will tell you. This particular component is called high pressure oil pump, which develops the pressure injection pressure from 100 to 250 bar. From where the drive gets this pump, the drive from crankshaft and get, there is again this small device is called injection actuation pressure valve. The purpose of the injection actuation pressure valve to change, to alter, to vary the volume and pressure of this actuation oil, volume and pressure of this actuation oil as demanded by the system as per the load variations in the engine. This acts, and through this valve the volume and pressure both are changed as per the requirement of the engine. How this IAP valve operates, that also I will tell you. So now diesel circuit is over, high pressure oil circuit is over. Whatever the oil is coming from the return line, it goes to the, all this line goes to the tank again, right? The next circuit is the electronic circuit. This is called the electronic control unit of the engine. This is fitted in the engine. The job of this electronic control unit is governing the fuel quantity and injection timing and injection pressure. These three jobs are done by this electronic control module, not directly, through the different components. This is nothing but brain of the fuel injection system, and the way the centrifugal governor is fitted in the mechanical fuel injection system, same job it does, but more precisely, maybe precision levels may be 100 times over the mechanical centrifugal governor. How this electronic control unit works, that I am going to explain you. This is a powerful computer fitted in the engine. What job this does means, it takes the signals from various points of the engine. First of all, it takes the inputs. After taking the input, it decides what is the fuel quantity is required at that moment of the engine, and what should be the injection duration, and what should be the injection pressure. It just decides in the fraction of seconds, maybe to the precision of 2 milliseconds. That is that much faster it thinks and acts. So how it thinks? It takes the inputs from various sensors, electronic sensor. I am going to explain about some of the sensors. For example, this is called speed sensor and timing sensor. This is the flywheel. Okay, example I will tell, this is the flywheel. So one sensor tells to this ECU at what speed the engine is running. Suppose load suddenly increases on the engine RPM tries to go down. Immediately tells to the ECM the RPM is dropping. Or the load is decreased on the engine. Suddenly engine tries to rotate at high speed, and immediately it responds to engine speed is increasing. So this is one input. The second input is the timing. At what time which injection has to fire, which cylinder has to be fired, in which injector the injection has to be applied. This is called a timing sensor. The other sensor is boost pressure sensor. What is meant by boost pressure sensor? It is fitted after the turbocharger in the inlet piping. Means with what amount of inlet air is being passed inside the engine. The inlet air pressure is more, means the more quantity of air is entering into the cylinder. So how much quantity is air is entering and how much fuel is required to for efficient burning of that particular quantity air. So this sensor sends the quantity of air is being charged in the cylinder. The next sensor can be called as atmospheric pressure sensor. Atmospheric pressure sensor means, for your information, the atmospheric pressure will be dropping as altitude is increased. For example, if the atmospheric pressure is 14.6 bar at zero level, at sea level, as we climb high altitudes, the pressure going on dropping. Means when the atmospheric pressure air drops, the density of air also drops. So when the density of the air also drops, we have discussed in the previous videos, the volumetric efficiency falls down. The oxygen content also drops. This ECM takes the signals from this sensor also, what is the atmospheric pressure. Accordingly, it will calculate the injection quantity. Then another sensor, oil pressure sensor. What is the oil pressure? Is it at required level or less than the required level? Immediately it says stop the fuel. There is something problem. So don't supply any oil pressure. Then another one is called actually fuel pressure sensor. Whether the fuel what is charged to the injectors or with recommended pressure or there is a less pressure. Yes, less pressure, there is some problem in the system. Maybe regulator valve or maybe pump. Repair that one. Next, oil level sensor. Engine oil should be adequate level. If it is less, the engine is going to be seized. Okay, oil levels. Then the coolant temperature sensor. The engine temperature should be a desired level, recommended level, 95 degrees Celsius, 95 degrees approximately. Okay, it should not be more and it should not be less than 80 degrees. So it regulates accordingly the fuel quantity. Next, coolant level sensor. Then one more sensor. What we do in the cars normally, we will press the accelerator by mechanical means. So accelerator is increased. Here it is called throttle sensor. So acceleration also is done through the electronic sensor. We want to run the car or vehicle at 2000 rpm or 2500 rpm or 1500 rpm because we want to go speed or we want to reduce the speed, whatever may be. So the rpm should be under our control. We will give inputs through this throttle sensor. This engine has to be run at so and so speed. It takes the input from this throttle sensor also. So it is taking the inputs from all these sensors. Then it listen to the speed sensor also. Yes, speed is increasing, speed is decreasing. Okay, and the complete processing will be done in this microcomputer, and it sends the signal to two places. One place is to the IAP valve. Mr. HUI pump, you pump now more quantity oil because engine needs more pressure, more injection pressure. So quantity means this IAP valve changes the movement of the swash plate inside to increase the or decrease the volume. Then another signal goes to the injectors, solenoids. This solenoid mainly does two jobs. One is controlling the flow of the diesel. Diesel quantity is maintained, diesel metering is maintained through this operation of the solenoid, and also injection timing. Let us look how this electronic unit injectors looks. This is HEUI injector, hydraulically actuated electronic unit injector. This is the solenoid. This is the injector body. This is the fuel inlet passage. There will be exhaust passage. This is called needle valve, okay, or nozzle. This thing and all. Micro holes will be there to spray the fuel. Okay. The injection actuation pressure, as I told you, will be performed through the high pressure oil. Inside there will be passage, so the plunger and barrel will be pressed with the hydraulic pressure. This is the solenoid to control the flow of the fuel. This is mechanically actuated. Here hydraulically actuated. This is mechanically actuated through rocker arm, push rod and camshaft. And the solenoid function will be same. Both this solenoid and this solenoid function will be same. This is the cross section of the mechanically actuated unit injector. You can see this is the solenoid. This is the solenoid fuel passage inside. There is a valve is there. The valve movement will be in corresponding to the energization, de-energization of the solenoid. Then oil is available up to this chamber, up to here, okay, and oil return line. When pressure is created over this piston, okay, plunger is moved downwards. Whatever the fuel is available here, it is pressed here, and the fuel passes like this, and it is this needle valve is lifted upwards against this spring force and fuel will be sprayed in the atomization form. The fuel injection pressure in the electronic injection will be up to 30,000 psi, means almost 2000 bar, up to 2000 bar, depending upon the engine design. Whereas in mechanical injectors, the pressure will be around 600 to 700 bar. It is almost 3 times more than the mechanical unit injection pressure. So more pressure, more atomization, more occupancy of the combustion area and effective combustion. This is called electronic control unit. Inside there will be complete circuit board, control unit, all these things will be there. I'm going to explain with a simple diagram how this injection is taking place in an electronic unit injector. See this figure. If you assume this is the injector and this is the electronic solenoid, this is a solenoid valve, and this is the plunger or piston which is actuated through a camshaft. Okay. In this position, fuel is coming here. The piston is in this position. It is the fuel, whatever is coming from the transfer pump is filled all these places. This is a injector plunger. These places are filled and this valve passage is opened. The fuel oil, after filling all these vacant places, will freely go to the tank. This is called flushing stage. This is called overflow phase. What happened here? Cam is rotated clockwise, little bit up to here. So it is rotated. When it is rotated from this axis, the piston is pushed downwards. When the piston is moved downward, this passage is closed, inlet passage is closed, but exhaust passage is not closed because the solenoid is not energized. So the pressure is created. When the pressure is created, so this is any overflow is there, it will be going through this thing and this is overflow phase, and the cam is rotated further. The cam is rotated further and the plunger or piston is further moved downwards, creating pressure and energizes at the same time energizing the solenoid. When the solenoid is energized, this valve is pulled upwards and this passage is closed. You can see this slot is moved upwards and this passage is closed. When this passage is closed, fuel cannot escape from here. It is closed here, it is closed here. Whatever is fuel is there, it has to pass through only injection needle valve because of this high pressure. The high pressure is created, injection needle valve is lifted here, and as I told you, pressure up to the 30,000 psi is created and injection is performed in the fine atomization form. And the next phase, the camshaft is rotated till the end of the lobe, injection is completed, and immediately the solenoid is de-energized here. The plunger has come down here, you can see, and whatever the pressure is there, the pressure is released here. Actually, what is the pressure? It is released here. The cycle completes. The opening and closing of the valve determines the injection time and quantity of fuel. This valve opening, whatever is there, okay, opening and closing of the valve determines the injection time and quantity of the fuel. And how the solenoid works actually with the signals from the ECM. If you cut this electronic injector, which is actuated through mechanical means, the internal components looks like that. This is the plunger, this is the spring, return spring, this is the plunger, okay, this is the fuel. Here actually fuel is coming like this. This is the solenoid, this is the solenoid valve, freely flowing here and going return. Okay, the fuel is available up to this needle valve. The next phase, this valve is closed. Okay, please don't get confused with this diagram. Okay, just follow only arrow. This valve is closed here. This valve is closed and the plunger is pushed downwards. You can see the gap is reduced here. Plunger is pushed here. You can see the gap here also is reduced. So when it's pushing, because this valve is closed, the pressure is created here. Needle valve is lifted here. The injection has taken place in the fine atomization form. This is a mechanically actuated injector. This is hydraulically actuated unit injector. You can see almost all components are the same except this green line. Instead of mechanical actuation, this is hydraulic actuation. The green line indicates the hydraulic pressurized high pressure hydraulic oil. This is the plunger. And how this hydraulic pumps looks like? This is actually variable displacement axial piston pump, whereas the transfer pump is the simple gear pump. Generally, you can see, you might have seen the gear pumps, vane pumps, gerotor pumps, centrifugal pumps. This is the variable displacement axial piston pump. This type of pumps are generally used for very high pressure applications. Means excavator, hydraulic excavator main pumps, hydraulic excavator swing motors, crawler motors, all these things and all. So how this functions? There are three. So this is the IAP valve, what I already explained you. It takes the signal from the ECU, and this piston movement will be there based on the signals from the electronic control unit, and based on the piston's movement, this is called swash plate. The swash plate angle is increased, means it is pushed like this, it is pulled like this, means it is pushed like this, means the volume is increased, the displacement volume of the piston is increased. The splash plate angle is reduced, the displacement volume is reduced. Less displacement value, less volume discharge, less pressure. More displacement value, more volume discharge, more pressure. You can see how it's working. This is suction zone, this is delivery zone. Okay, the blue line indicates the sucking of the oil. Okay, it will be there will be 9 pistons to 11 pistons depending on the model. The shaft will be rotating. The pistons, here it is only for illustration purpose, only 2 pistons have shown. So there will be 9 pistons. It will be rotating as a unit. This valve plate, this cylinder block and swash plate fitted with assembled with the pistons will be rotating a single unit, but as it starts rotating from top to bottom or bottom to top, the movement, the pistons will be moving horizontally like this, inside and outside. So when the piston moves from here to here, oil will be sucked, and again piston moves towards the plate, oil will be pushed out. So what are the advantages of the electronic fuel system? I am going to tell you. Advantages are faster response to the load variations on the engine. ECU operates at almost 60 times per second and even more. I told you, even some ECMs are designed to respond at every 2 milliseconds. ECU decides the fuel quantity based on the various inputs from the engine, unlike simple mechanical governor in the conventional system. Higher injection pressure, better fuel atomization. Because of the higher injection pressure, there will be better fuel atomization and better spray area, and ultimately better combustion efficiency. Good combustion, good quality combustion are lowering the pollutant levels, that is nitrous oxide, particulate matter, carbon monoxide and other pollutants. Optimum fuel utilization, that is increased power. So maximum power for every drop of the fuel burn. Then altitude compensation. What is meant by altitude compensation? As I already told you, as the altitude levels are increasing, the air density drops down and oxygen levels drops down. So the ECM decides the fuel quantity based on the even altitude variations also, which will not happen in the mechanical injection system. And another advantage is the longer life of all these components, because all these components are designed with highest precision technology and made with the high quality material, whether it is injectors, whether it is the ECM, whether it is a piping or the HA pump, whatever may be. They give very longer life, okay? So that the maintenance cost is cheaper than the conventional system. And the only one thing care a user has to take is he should ensure that the clean fuel is always supplied to the system. If the fuel is not clean, then there will be more damages than the conventional diesel system, because these parts are very precision machined and with close tolerances. If any impurities goes inside the components, that particular component will be damaged. So necessary care has to be taken in supplying the cleaner fuel. So friends, if you have any questions or queries, please mail to me. Thank you.